Hello friends, welcome back to the Python programming session. In today's session, let's see the generator function concept in Python programming language. So what are generator functions? Generator functions are similar to the normal functions which are defined by the def keyword. Even the generator function we define with def keyword just like normal functions. But normal functions have a return keyword and generator functions have a yield keyword. So generator function uses a yield keyword instead of the return keyword. Or we can say if the body of any function contains a yield statement, then it becomes a generator function. So one of the example is we are having a function called func. So it is defined with def keyword itself. Then I'm having a for loop for I in range of 10. If I percentage 2 modulo 2, not percentage, if I modulo 2 equal to 0, that is I value when it is divided by 2, if it becomes 0, then I'm saying yield I. So instead of return, I'm using yield statement. So this example becomes a generator function. There are some more concepts in the generator function which we need to understand. The yield statement is responsible for controlling the flow of the generator function. So basically it controls the generator function. Whenever the function encounters the yield statement, it pauses the function execution by saving all states and yields back to the caller. So whenever the function gets executed and when it encounters the yield statement, it returns to the caller statement and it saves all the local variable state values. So whatever local variable values will be there, it will save all those values and the control comes to the calling statement. So that is what we did by this particular statement. Later it resumes execution from a successive function is called. So when the function is called again, it won't execute from the beginning. It will continue with the next statement. So whatever statement is after this, it will continue. So over here when yield was encountered, the function came back to the calling statement. And again when we call this particular function, it resumes its execution from the statement below the yield statement. And since it's a for loop, it executes the second value in the for loop. So what we have to remember here is when the function encounters the yield statement, it pauses the function execution by saving all the local variable values and later it resumes execution when a successive function is called. So when the function is called again, it will continue. It won't execute from the beginning, whereas it will continue from the stopped location, from the yield location. Also, we can use multiple yield statements in a generator function. So now let's look at with an help of an example. Def func is my function. Then I'm having a for statement for I in range 110 if I modulo 2 equal to 0, then I'm saying yield I. So instead of the return statement, we're giving the yield statement because it's a generator function. This is the function definition. Now let me call my function by saying output equal to func. So I'm calling my function. So friends, here what happens actually? So now if I say print output, So now let me run the code. So here it returns a generator object. So whenever we say output equal to func, the function gets called and it won't execute the part within the function, whereas it will return the generator object, the function object. So now when I'm saying print output, it does not have any output, it will have the generator object. Now if I want to get the values, I have to use the next statement, print next of output. So now when I run the code, print output return the generator object and next will return the value. When I give next of the generator object, it will execute within the function for I in range of 10. So initially it will be 0. 0 modulo 2, is it equal to 0? Yes. So it will yield 0 and it will print 0. Since I've got only one next object, next function, it returns only 0. Now if I want the second value, then I have to say print next of output. Now if I execute the code, it will give 0 and then the next one is 2. 2 is divisible by 2, so the remainder is 2. So in this way, if I give some more next objects, so now when I execute the code, it will give 0 for the first next object, 2 for the next, 4, 6, 8, and again if I give next object, there are no more values, so it will throw an exception called stop iteration. So it will throw an exception called stop iteration and gets terminated from the generator function. So this is how the generator function works. So initially when I say output equal to func, output will be having the generator object. Only when I use the next of the generator object, I get the values. So this is how it works. And now let us see an example with multiple yield statements. So let me have my show function str1 equal to initial yield str1. Then I'm having my str2 which is equal to intermediate yield str2. Then I'm having str3 which is equal to advanced and then yield str3. So now let me call my function with the help of object equal to show. So I'm calling my function over here. So object basically will have the generator object. Now if I want to print str1 value, then I have to use the next function. So I have to say print next of obj, that is the generator object, then it will print str1. And when I call this particular next function again, print next of obj, then it will continue. The initial yield statement will return str1. So when I print it, it will print initial. Again, when I call my next function, it will continue. It won't start from the initial thing. It will continue to the next point after the yield statement and it will yield str2. So when I give print next of obj for the second time, it will give intermediate. Now if I say print next of obj for the third time if I give, it will give advanced. So initial, intermediate and advanced. So these values are not stored in memory. As we give the next statement, it will give the values. So it is very memory efficient. Generator functions are memory efficient. And now let's see the difference between the normal and generator function. In a normal function, we can have one return statement. In a generated function can contain more than one yield statement. It does not have a return statement, but it can contain more than one yield statements. When a normal function encounters the return statement, so when it encounters the return statement, the function is terminated completely and the control is transferred to the caller. When a generator function encounters a yield statement, the function is not terminated, but it is paused and the control is transferred to the calling statement. Local variables and the states are not remembered in normal functions. Local variables and the states are remembered between successive calls. And when all the items have been executed in the generator function and there are no more items to be printed, when I use the next statement, there is no other item, then a stop iteration exception is raised automatically and the function is terminated. So this example we saw, and now let's move ahead with generator expression. Friends, we all know list comprehension. So z equal to x to the power of 3 for x in list 1. List 1 I'm having some elements. So I'm performing the cube of those elements. So list comprehension will give the result in this particular manner. All the values will be given out at once. But when I use a generator expression, we use the parenthesis instead of the square brackets. If we use square brackets, it becomes list comprehension. And if we use parenthesis, it becomes generator expression. So now let's look into it practically. So let me have my list 1 equal to 1, 2, 3 and 4. And now let me have my list comprehension. So z equal to square brackets x to the power of 3 for x in list 1. So now if I say print z, let's see what the output would be. We got the cube of 1, that is 1, cube of 2 is 8, cube of 3 is 27 and cube of 4 is 64. So for these 4 elements we got the output at once. Now let's see with the help of a generator expression. I'll give it as a equal to parenthesis, the same condition but within the parenthesis. And now if I say print a, so what would be the output? For list it gave 1, 8, 27, 64, but for a it gave a generator X object. So it gave a generator object. So how do I get these values 1, 8, 27, 64 for the generator expression? For this I have to use print next of a. So when I use this, I get the first element, that is 1. So if I want the second element, I have to use this expression again. And if I want a third one, so if I give it 4 times, for the first next I get 1, for the next x I get 8, for the next I get 27 and for the next I get 64. So 1, 8, 27, 64. So it does not save the elements in the memory. It displays one at a time. So generator expressions are very much memory efficient. So this we have to remember. And now let's use display a multiplication table using generators. So def table n is the value which I'm taking for I in range 1 to 11, 1 comma 11. So for I in range 1 comma 11, I'm yielding n into I, n into I. Then I'm saying I equal to I plus 1. Now I have to call the function. So for I in range, for I in table, and I'm passing the value 15, print I. So this prints the table. The 15 ones are multiplication table. So how does it work? Initially the call is over here. I'm calling my table passing 15. So n will have the value 15. For I in range 1 to 11, I takes the first value, that is 1. So n is 15, I is 1. 15 into 1 is 15. So it reached the yield statement. So it will come and print 15. Now the loop continues. I again calls 15. Again calls the table. So in this case, it will continue with the next step, that is I equal to I plus 1. So I becomes 2. So it is within the range. So 15 into 2 is 30. So it will remember the previous local variable state values and it will execute without executing it from the beginning. It will continue the execution. It won't execute from the beginning. After the yield statement, whatever statement is there, it will continue executing from that particular statement. So in this way, it remembers the local variable previous state values and continues with the next execution on the consecutive calls of the function. So hope so friends, it was clear for you the generator functions in Python programming language. So whenever we have a yield keyword, then the function becomes a generator function and we can get the output with the for loop or with the next function. So when I use the next method or function on the generator object, then I get the values, whatever the yield value it yields, and can print that particular value. So hope so friends, it was clear for you. Then we saw the difference between normal function, generator functions, generator expression versus list comprehension, and a small multiplication table example using generators. Hope so friends, it was clear for you. If you have any doubts, please do reach to me out in the comment section. If you like my video, click on the like button and please do subscribe to my channel to get notification of my new videos. Till then, see you. Bye bye.